the University of Washington Computer Science and Engineering Distinguished Lecture Series.
I'd like to welcome you to this distinguished lecture. Our speaker today is Dan Jurafsky, who is professor and chair of linguistics, also appointed in computer science at Stanford. To say that Dan has had a profound impact on computational linguistics and natural language processing would be a profound understatement. He's literally written the textbook 3 times. The new edition is coming out in time for this quarter, maybe? Dan has worked on a variety of different problems, some of which he'll touch on today. Apart from writing the textbook, he's transformed our thinking by becoming a leader in the use of natural language processing and computational linguistics techniques in the social and behavioral sciences. He won a MacArthur Award back in 2002, before he even really got into all of this stuff for his earlier work. If you're working in NLP, you've surely read several of Dan's papers. And so we're really excited to have him here today. And so I will just let him take it away from here.
Thanks, Noah. OK, thanks for having me. OK, I want to talk about some fun computational linguistic things. And I'm going to start with the most fun thing, which is the language of food. I have a fun, popular book out about this. And so I want to start with a metaphor from food. And I promise I will get to equations soon. And I want to start by talking about the fact that America is the land of immigrants. We are an immigrant nation. And we can tell this by looking at the names we call our national foods. Hamburgers, frankfurters, and French fries all have names of foreign places in them. And I'm going to show you two that ketchup does also. And there's Hamburg, and there's Frankfurt. And well, actually, French fries are Belgian, but that's close enough. But I want to talk about ketchup. And I want you to notice that the bottle of ketchup says tomato ketchup on it. It doesn't just say ketchup. But ketchup is made of tomatoes, so why would the ketchup bottle mention the tomatoes? We don't normally mention obvious ingredients in things. And the fact that it says tomato ketchup is a hint that the history of ketchup is not what it seems. So imagine, it's 2,000 years ago, imagine that you are a fisherman. You're living in Southeast Asia, what's now southern China, the Fujian and Guangdong provinces, or you're living in what's now Vietnam, Cambodia, Thailand. And you're a fisherman, and the water dries up in the dry season, and you've got to preserve your fish. So how do you do this? And here's a picture of what you do. You take your fish, and you layer it with salt and rice, fish, salt, rice, in a big basket, put a stone on the top, and you go away for a few months. And when you come back, the rice has undergone lactic fermentation. It's all gooey and very icky, but the lactic acid has pickled the fish, and you get this kind of, it's like a ham consistency. And we know this because Chinese ethnographers wrote about this around 500 AD, about these weird southerners and their fish, preserved fish foods. And it's still made, actually, in hill tribes of southwest China, the same exact recipe. It's been made for thousands of years. Anyway, so this recipe, this lactic acid fermentation of fish and rice and salt, spread around the Chinese Empire, around the Han Dynasty, around the time of Christ. The Chinese Empire moves south into this area of the southeast. The locals get assimilated into the Chinese Empire. These fish products spread throughout China. And they spread to even areas of Chinese control, like Japan. So by 700 AD, this fermented fish and rice comes to Japan, where it's called Nara Sushi. And that dish slowly changes. So by the 18th century, instead of getting goopy, fermented, icky, lactic rice that you scrape away, you use beautiful fresh rice, and you just add vinegar for the sourness. And instead of pickling the fish, once you have refrigeration and ice, you just eat the fish fresh. So the modern dish of sushi is a descendant of this preserved fish dish. And there are lots of other descendants of this dish. So here's one of them is fish sauce. Here's a picture of a bottle of fish sauce. So fish sauce is used now in Vietnamese food and Thai food. It's fish. You basically put a lot of fish and salt into a barrel, and you go away. And the enzymes in the fish stomach dissolve the whole thing. And ethnic Chinese sailors from the south part of China settled around Southeast Asia, spreading these fish sauces. And I put stars where there are large ethnic Chinese communities in those regions. They carried around fish sauce, and they also, Chinese wine is made in a different process than European liquor, and it's made by a kind of yeast ferment, and that's the red yeast ferment. And the lees at the bottom of, when you make wine, there's lees at the bottom. That's the leftover lees, and those are used to make a very delicious chicken in red rice ferment dish. So these rice pastes and fish sauces are brought all the way around Southeast Asia. And in fact, you can see a distinction in Asia between the south of that dotted line, people ferment fish products, and north of that line, people ferment soy products. All right. Oh, and here's me at a fish sauce factory in Vietnam on my honeymoon. It was very romantic. OK, so right about this time, 1600, it's the age of European exploration. The British, the Dutch, the Portuguese, they're all very excited to go to Asia because that's where the money is. That Asia is the Silicon Valley of the 1600s. That's where spices are, textiles. Europe hasn't had their Industrial Revolution yet. All the manufacturing is done in Asia. It's done in Bengal. It's done in China. And so you're a sailor on this ship now, and what do you drink on these long 9-month voyages to Asia? It's hard to get fresh water, so you drink wine and beer, and hops haven't been invented. Hops is the thing that makes beer, is a preservative for beer, and it's actually been invented, and the Dutch have it, but the British are very conservative, and they don't believe in this newfangled continental hops thing yet. And so they're drinking all this kind of sour beer and wine, and they get to Indonesia, and they're very excited because in Indonesia, those same ethnic Chinese are making arak. And what is arak? Arak is the ancestor of rum. So distillation, the technology of boiling wine and letting the alcohol drip off of a kind of a lid off the pot and collect the alcohol separately and making hard liquor, was invented by the Chinese once and by the Arabs once, and there's a big fight about whether those were influenced each other in some way. But certainly the Europeans didn't invent it. They borrowed it from the Arabs. And so arak was in fact called by the Arabic name for sweat, for the distillate kind of dripping off of the top. Anyway, arak was distilled from that same red rice that those lovely sauces were made of, and red rice wine and sugar. And the British were very excited to get it. So the navies, who've been trying to, give stuff to drink to all the sailors, were so excited to find something that does not go bad in the heat, and that if you add it to water, it kills germs. This is like the miracle drug. So they buy thousands of barrels of arak by 1609. By 1700, it's the common drink of all Europeans in Asia. And in fact, they add limes to this arak, which they're carrying limes against scurvy. They add limes to the arak, add some of the palm sugar, and they've invented the world's first cocktail, which is called punch. And then all cocktails descend from that. And while they're buying this arak, the Navy picks up local bottles of this same fish sauce that they've been making. We don't, now we use the Vietnamese name or the Thai name for this fish sauce, but back then they called it by the name that was used by these particular southern Chinese sailors, the Zhangzhou dialect of Minanhua, the southern Min dialect. And the name for fish sauce in that southern dialect is Ketchup. Ge is an old, now it's a died out word for a kind of salted fish. Now this character means something else. It means salmon or other things. But it used to mean some kind of salted fish, and dup is the word for sauce in many southern dialects. So they take this ketchup, this fish sauce, they call it ketchup, and they bring it home to Europe. And we know this because there are amazing accounts written by the British East India Company about their trips to Asia and how ketchup, which is, again, their word for fish sauce, was an important trade commodity. And here's a quote from one of them. "Soy comes in tubs from Japan, and the best ketchup from Tonkin." Tonkin means the north part of Vietnam. "Yet good of both sorts are made and sold very cheap in China." So they went to Hong Kong, and they bought fish sauce in Hong Kong. And he says, "I know not a more profitable commodity." So what do you do when you have a profitable, exotic, imported luxury? Immediately, there became knockoffs. People created knockoff ketchups. Here's a recipe for a British knockoff ketchup. You can see it has anchovies, it has cloves and pepper, it's got shallots, it's got a quart of mushrooms. And you can tell that it's a knockoff because it says at the very end, this is even better than that. India is the old word for Asia. This is even better than that Asian stuff. This is like British ketchup. And British ketchup changed slowly over the years. So by 1800, there was a walnut ketchup. This is Jane Austen's family recipe for walnut ketchup. Soon afterwards, tomatoes come from the New World. Tomatoes came from Mexico, and they filtered through Portugal and Spain and finally got to England many, many years later. It took a couple hundred years for the British to be willing to eat them, and even later for the Americans to eat them. And you can see that this is not our modern tomato ketchup. This is a salty, savory. It's got anchovies and tomatoes. It's very much of the salty, fishy sauces that are its ancestors. But then something happens after the Civil War, which is sugar becomes much cheaper. And we start adding sugar to all sorts of things, especially in America. The anchovies disappear. We add a lot of sugar to the recipe. Ketchup turns into this kind of sweet and sour chutney, and you end up with modern tomato ketchup. All right, so why am I telling you this? Why is this relevant for computer science? I want to claim that the word ketchup actually tells you something about the history of innovation. So if you think about it, a recipe is just a technology. And if you look at the very long, but this is a technology that we have a lot of history about. If you look at this, tomato ketchup is a cousin, many times removed, of sushi, and it's a cousin of fish, it's a descendant of fish sauce, and it's a cousin of all of these anchovy and mushroom ketchups. So in each generation, some chef took some foreign food, modified it to suit his particular tastes, and changed the recipe. So the intuition about the history of science is that innovation happens at these boundaries between cultures, and especially when someone goes to some neighboring place, brings home something, and influences his own culture, or the other way around. Someone goes to some other place, brings something there, and influences them. And I want to use this ketchup theory of innovation now to talk about the history of computational linguistics. And so this is a big project we have with a lot of people involved looking at what I call computational history of science. And I want to give you just one result from this. It's a very much ongoing project. We have a lot of people and a lot of stuff we're working on. But the results I'm going to tell you about are Ashton Anderson's results. So if you have studied the history of science at all, you've probably heard of Thomas Kuhn and this idea that science progresses by revolutions, that science does not progress by people incrementally fixing things, but that things build up, and someone has problems build up in the current theory, and it doesn't quite account for things, and someone says, wait a minute, let's do it this other way, switches things around, and everybody borrows this new way of doing things. And that's a model of internal revolution. So somebody, Einstein in physics changes what the physics was before. But we were interested in external influences. Could we see how neighboring fields affect the history of a field? And we were inspired by this history of ketchup, where we saw in innovation in recipes, it's very much you borrow from somebody else. So let's see what happens. So we looked at the standard corpus for computational linguistics, the ACL anthology corpus. It's 20,000 papers in computational linguistics. And the advantage of this data set is that the citation graph has been built. This is by Drago Rad of University of Michigan. And so we have the citation graph. The authors have been all deduplicated and disambiguated. We have all the text. So it's a beautiful, coherent corpus. And then we ran topic models over this corpus. And very briefly, for those of you who don't know what a topic model is just a way of doing soft clustering of words. So if you think of a paper, up there I put a picture of papers, and then across the rows I have different topics. I have a topic called anaphora topic, and a topic called parsing topic. And paper 1 is 0.12 about anaphora, and 0.08 about parsing, and 0.02 about machine translation, and so on. So a topic model, in an unsupervised way, comes up with clusters of words that indicate topics. Here's some clusters of words indicating topics in this data set. And for every paper, gives you a loading across topics. It's a probability distribution over topics. Every paper has a vector of 73 probabilities. So far, so good? All right, so we ran topic modeling on this data set. So now we have the citation graph and the authors and all the topics. And now we can ask questions like, what are people working on in a particular year, by just summing all over papers in a particular year and saying, what's the topic loading on the topics for that year? What topics are popular when? So here's a pair of topics. Here's a particular older method that was dying out, say kind of dead by 2005. And here's the new statistical models that came into natural language processing about, as we can see, right about 1988. So the blue line shows this very sharp rise in this new topic. New idea, innovation, comes into the field very sharply all of a sudden. Old method dies. And the old method, by the way, is the one I was trained in grad school. And so I was in grad school here. So I'm the generation of students that was very excited by this. All right, so what is this? What happened in 1988? we call it the Statistical Revolution. So something big happened in 1988. People switched to using probabilistic models in machine learning. Machine learning entered natural language processing, and probabilistic models entered. So how can we figure out what caused that revolution? So we just looked at all the papers from that year that had high loading on that topic, had a high weight for that topic. And what were those papers? Here's some papers that appeared in 1988 that were very highly loaded on this statistics topic. The very first part of speech tag, not the very first, an early part of speech tagging paper, the IBM group paper on proposing statistical machine translation, lots of work on speech recognition, lots of work on Markov modeling, work about pronunciation of names and so on. And if we looked at all of these papers and asked what was in common among all these papers, it turns out many of them came from two laboratories, Bell Labs and IBM Labs, and all of them were written by people who were electrical engineers or people who had worked with electrical engineers. So here's this new innovation that comes into computer science. It's very clear where it comes from. It comes from people in another field who have a different kind of math, and they bring their math to computer science. So they bring these ideas to computational linguists. The linguists start borrowing them. And this is a perfect example of this Ketchup model of innovation. Some neighbor shows up at your conference, presents a paper on something, and the students are like, oh, I could do that. And the field changes. So interdisciplinary is the key role in how this particular innovation happened. But so far, all I've said was there was no people working on probability in 87, and all of a sudden there were people in 88. What's more interesting is to ask, how did individual researchers change their career to adopt this new innovation? So I want to talk about bodies now. So before that, I just said, oh, they were working on this topic, and then they're working on that topic. Let's look at how actual humans who were working on some topic in 2003, how did they adopt this new topic? Maybe that could tell us about this propagation. So we look at now, since we have author disambiguation, we look at the authors in 2002 and see what happened to them in 2003. And what we do is we cluster all of our 73 topics, never mind the clusters. And each dot in this graph is a cluster of 5 to 7 topics, so a grouping of topics that were worked on at similar periods. And I'm showing you snapshots of time. This is the early 80s, the mid to late 80s, the early 90s. And each period, a dot is a topic that people are working on, and the size of the dot is how many people are working on it. And an arrow is an actual person worked on that topic in this 4-year period and then worked on the end of the arrow in the second period. So in topic 9, the early language understanding topics, never mind the labels, you probably can't read them anyway. But in the early period, people were working on particular topics, and then the next year they kept working on the same topic because that arrow is very thick up there. And then starting in the late 80s, right around 1987, 89, they started working on this little topic in the middle. I've labeled government topic. I'll talk about that later. And then by the early 90s, there's a lot of people working on that middle topic. And you can see a big fat arrow. People keep working on this topic. And then from that middle topic, they extend out to lots of later topics. And I call this the hourglass. People were working on lots of early topics in the 70s and 80s. They start working on this mystery topic, topic 8. And then from topic 8, all these people who were working on topic 8 now work on everything else. And if you look at the modern field as of, let's say 10 years ago, now we have a bunch of coherent things that people are all working on, and they're working on together and moving around among them. We have a coherent modern field. So what is this mysterious topic 8 that people pass through? Topic 8 was the DARPA bake-offs. Bake-off was a required competition that computer scientists who worked in either speech or natural language processing had to go to as a condition of their grants. They had to show up at this conference and present their work. They worked on shared tasks, shared evaluations, and it was a very interdisciplinary group, and things got replicated. So but because they were forced to work together, people were forced to go to this other place. Electrical engineers had to show up and talk to computer scientists. It's very annoying, and present these ideas. And then all the grad students were very excited. All right, we can look at the ramifications of this. So I'm showing you in this graph the movement of conferences through topic space. So this is three of the big conferences in the field: CoLing, ACL, and EMNLP. And these are the red and green are the older conferences, and the little tiny blue line is the newer the newer empirical conference that was formed more statistically and after the Statistical Revolution. And you can see that the conferences over time move toward this new space, new place in topic space, where they're working on these more empirical and statistical things. They move toward this new conference. We can even look at people coming and going. So this graph asks about author retention. If I publish in the field in a particular year, what's the likelihood that I'll come back and publish the next year? And you can see that over time, if you just plotted a single regression, people are coming to the field is growing, like most fields in computer science. But there's a weird big hump. And that hump exactly correlates with the required DARPA bake-off. So what is that hump? We looked at the people in that hump. And those people were speech people from electrical engineering who were forced to come. Those are the hump people. They were forced to come to these conferences. They presented their ideas, and most of them went home. So it turns out most people who presented in that conference disappeared, and that's why they disappeared from this graph. A few of them stayed in natural language processing. Actually, one of my persons in my data set is Mari Ostendorf, who came to computer science from electrical engineering in that period and kept playing with computer scientists afterwards. Very exciting. We call this the pollination model of the spread of innovation. So you can imagine an alternative colonization model. It says ideas spread because somebody switches departments or switches universities and brings this new idea with them. And that's not what we found here. People came, presented their papers, and went home. In fact, the IBM researchers, they didn't even go back to IBM. They left IBM and founded Renaissance and started predicting the stock market and made $1 billion. And so they moved on. So this pollination model, this is our new theoretical model of how we think now about one important way that the innovation spreads in academics. All right, so for this part of the talk, we've used the language, we use topic models, we use the linguistic behavior to define the innovation, to define this new rise of probabilistic models. And then we trace humans through the network of papers, finding the innovations came from neighboring fields, and it was kind of midwifed by this required, just like the internet, it was caused by the government forcing people to actually talk to each other. All right, so that's scientific innovation. I want to now turn to sideways to linguistic innovation. So that's how do ideas propagate, and I want to talk about how language propagates. And this is a project with Christian Danescu, Niculescu Mazil, and Bob West, and Yuri Leskovitz and Chris Potts. So here's, for those of you linguists in the room, here's a well-known mystery of human language change. So adolescent girls turn out to be the drivers of language change. So this graph here, just very briefly, I'm showing you a particular graph of adoption of a particular syntactic variant, age group along the x-axis, probability along the y-axis. And you can see that this little peak in most of these different syntactic variants is somewhere between 15 and 22. So women between 15 and 22 are most likely to adopt language changes. This is a well-known, I just picked one paper, one graph, but there's lots of such graphs and such papers in linguistics showing that this is a general fact about language change, at least in North America. So, but what we don't know is why. You could imagine theory, those of you who have teenagers would immediately say it's about rebellion and about teenage identity, and you could imagine a theory that says, no, it's about biology, and at a certain age you're ready to innovate, or you can imagine all sorts of theories, but we don't really know. And there's a second famous sociolinguistic fact, and the second fact is that that it's called adult language stability, or I call it adult freezing, that when you get to about 30, your language stops changing. So it's, again, different for different people, just like we see there's like differences in this graph for different people. But roughly speaking, if you're 60, you speak the same dialect you did when you were 25. So again, we don't know why. Is it biology? Is it really true? It's much harder to test these things because you've got to, how would you test this, right? You have to follow people around with microphones, right, for 50 years to see if they still speak, when they're 60 as they did when they're 25. So we had this idea that's much better for lazy people, which I am, and that is instead of following people around with microphones, just go online, find a community, and just scrape it and look at how the words change over time. So we picked the beer rating community. This was not because we like beer. although we do like beer. But Julian Macaulay, who's now at UC San Diego, who had this idea, the advantage of the beer community is it's a very long and loyal community. So people were on it for, we scraped 10 years. And people are very prolific posters of their beer reviews, which implies they're also very prolific drinkers of the beer. And anyway, so there's a million posts from 30,000 users. So we have a lot of language data over a lot of time, and we can watch people progress. Hundreds of millions of words. This is an enormous, and this is one little community. I'll talk about others. So here's a sample beer review, just so you see what beer reviews look like. This is, as you could probably tell, a negative beer review. Bad, bad, bad. I'll give you a second to read it because it's fun. All right, this is an unhappy beer. So let's talk about language change in this community. So here's a random change that happened to happen. It's kind of a change in convention more than language, this particular example. People used to say the word aroma when they were describing the smell of a beer, and they switched at some point in the community to using the letter S or the word smell. So the convention changed from just the word aroma to the word smell. And this just shows you the two conventions. You know, aroma was big in the early period, and smell became big in the later period. Random change in the community. Communities change. So first of all, let's look at the age of the speakers and see how that correlates with their adoption of innovation. So sure enough, the left graph is only users who joined in 2003. I'm going to call them the old users. So old users, they used aroma. This new smell convention comes, they ignore it, and they even use aroma more. They emphasize their use of the old convention. Anybody who joined in 2005, that's the young users, they, even though aroma is the dominant convention still in that very first year, they nonetheless pick up on this new thing. It's new, they adopt it, and they take off with it. So sure enough, younger speakers adopt innovations, just as in science, it was the grad students who adopt the scientific innovations. We can look at individuals. So that was the community changing over time. We can look at individuals as they change over time. It happens that as you write reviews, if I normalize all your reviews from 0 to 100% of your reviews and just look at the usage of certain words, just the count percentage of usage of words, the percentage of reviews that use the word I drops over time, and people are beginning to learn the jargon of the field. Words like lacing and retention are beer jargon. So as you enter the field, you begin to learn the correct jargon of the field. So natural things that are happening, changes in users' vocabulary over time. The community is changing over time. It just happened that fruit terms became more popular in the 2000s. And so people began to use more fruit terms for beer and various other kinds of innovations. People started calling things gummy and rubbery. So various changes are happening in the community. And you can think about two ways about the link between how an individual changes their language and the community. I've shown a picture up here. Here's the community in 2001, and here's the community in 2011. So you can think of a group of people are speaking in some way, and then the group of people are speaking in another way, and a group of people are speaking to the distribution over how people speak. Or you can look at it as the life stage of the individual user. Some user joins the community. They're new to they're a baby in that community, and they mature in that community, and they leave the community. And we're going to follow the life stage of users through the community. So it's like a picture of people passing through this community. So let's look at the life stage of a person and look at how similar their language is to the rest of the community. So here's a graph where along the x-axis I've given you life stage, and along the y-axis I have how far are they from the community, where by distance to the community I mean the language model difference. How similar are my bigrams of the words I use in my posts to everybody else who posts except for me that month? And you can see that they start out far from the community, they get closer to the community, and then they get far away again. So where down is similar. This is a distance metric. So we're far from the community over my lifespan, somewhere between 30 and 50% of my life. I'm more similar to the community, and then I kind of drift away from the community. So we have these two phases. I'm learning the language of the community, and I'm somehow drifting away. So why would it be that users get far away from the community? You can imagine two hypotheses. One is the users are, these older users, they're adopting exciting new innovations, and everyone's ignoring them. So I'm adopting new things, but the community just happens not to adopt my language, and so I look more different because I'm changing. Or it could be that I stop changing, and the community changes without me. And I want to give you some evidence that we think it's hypothesis 2. That what's going on is the community keeps changing, because communities just always change, and at some point users just stop changing. So here's again life stage, and now I'm showing self-similarity. This is how similar are my paragraphs, my little beer reviews, to my previous beer reviews. And you can see that my similarity is going up. As I'm writing, I'm getting more and more like myself. My reviews are getting more similar to each other. I'm changing less and less. You can measure how progressive or conservative my language is. How much is my language like the language of the community last year or the community next year? So forward-looking linguistically or backward-looking linguistically. And early in your life stage, your language looks more like the future. And later in your life stage, each user looks more like the past, suggesting, again, that users are not changing. And you can even look at whether users are likely to adopt one of these new innovative words over time. And you can see that the adolescent period, that sort of peak right there in the middle, the peak reaction to change happens at the adolescent period. You're most likely to adopt new things, kind of about a third of the way through your life in the community, and then you're just kind of less likely to adopt these new terms that pass into the community. And what's exciting about this last graph is I've shown you with life stage, but we could show the same graph now with not normalized, to not just look at number of reviews people write. Some people write 100 reviews, some write 300, some write 500, some write 1,500. And no matter how many reviews you write, about a third of the way through your time writing reviews is your peak adoption of lexical innovations, and you just stop adopting things and you kind of freeze in your language for the rest of your lifetime in the community. And that's kind of a scary graph, because that suggests that no matter how old you are, once you stop innovating, I can predict your death in the community. So of course we want to do that. So we, because we're computer scientists and we like to predict things, and so here is our I give you the first 40 posts, you tell me when they're going to leave the community, predict the lifespan of the user. And there's lots of features you can use. This is a standard kind of task. Lots of features you can use as your baseline. But adding in all of these language features hugely improves our ability to predict when someone's going to leave. So someone's language is a great cue for when they're leaving the community. So in summary, we have our initial period of adaptation. The user's language, their language patterns rigidify. They're less likely to pick up on new innovations. They look like older users. They freeze in some way. So why this freezing? So I don't have a good answer to this yet, but we're still working on this. But there's two obvious theories. One says it's about learning theory. Once you know everything there is to know about the community, you've learned all the words, there's nothing more to learn, and you stop learning. You feel like, I'm a master already. There's no need for me to learn this newfangled thing. Or it could be about social relations. And I'm more tempted to believe this theory, which says in order to learn something, you have to be interested in learning it. If you're bored and not interested in learning it, you're not going to learn it. If you don't pay attention to other people's interesting new words, you're not going to learn them. And if you stop being invested in paying attention, therefore you stop innovating. And not being interested is sort of the exogenous variable that explains both why you're not innovating and why you leave. All right, so methodologically, here's a case where we can use online communities, look at their language, and study how language works in real life. And we find evidence for these things that have been suggested in real life communities, this adult language stability and this adolescence as period of greater innovation. And it suggests that adolescence and adulthood at least partially are relative facts, that we're all adolescents when we start doing something new, and we're all old people when we've been doing the same thing for a long time, which is why sabbaticals are really good, and I recommend you all take sabbaticals. But now we need to figure out what's going on. Like, what are the causes of this? And is it really this attention idea or something else going on? All right, I want to finish on one final topic. We've now talked about technological innovation and linguistic innovation, and I want to just look at some other fun things that, because all of these insights so far, if you think about it, have come from food. I want to talk about more food. And I want to talk about, start with identity. This work began with our study of potato chips. And it began because an undergraduate named Josh Friedman took my Language of Food freshman seminar, and we were all looking at different kinds of language. And Josh had the idea to look at the language on potato chip bags. And being a freshman and not having a lot of money, he just went to the store and took pictures of all the potato chip bags and brought them back. And we all studied them. And then later, with the vast financial power of Stanford University, we bought all 14 bags. And this is our corpus. That was our whole corpus, by the way, and this is a sample from the corpus. So it's all those words on the back. And we were inspired by Pierre Bourdieu, this famous French sociologist who studied French food in the 60s. And he said, he noticed, he was looking at the working class versus the professional class. And he noticed that there were differences in taste. The working class liked Strauss, and they liked these heavy starchy meals, cassoulet, which is this actually really delicious dish of beans and duck confit and sausage. It's really amazing. But the upper class, they liked Bach, they liked Bruegel, and they liked what were just coming into France in the early 60s, these curry and brown rice, these new ethnic foods. And he said, there is nothing better absolutely about curry than cassoulet. This is just a random marker of social distinction. It happens that cassoulet now is a fancy French food, but back then it was a peasant food. So he said, all we care about is societies need ways of distinguishing themselves from each other. People like to distinguish, and these are just random markers of the upper class. And he specifically said that, taste is negation of somebody else's taste. What it is to have a taste is just to be different than the other people. All you care about is defining yourself as being different. So that suggested, he said it very viscerally, sick-making of the taste of others. He's a very passionate writer. So we thought, well, let's look at that. Let's measure, just linguistically, all the words used to distinguish things from each other. Words like more or less, or least or best or unique, or negative words. And sure enough, all those distinctive words are much more frequent in the expensive chips. Words like best or different or less or any other. And especially words like no, not, or never. If you add a negative word, we ran a little regression, you're adding 4 cents to the price per ounce of your chip. My most expensive potato chip bag is this one. And every third word is no. We also found some fun side notes that the more expensive the chip, well, first of all, that all chips are health foods, which we didn't know beforehand. Kind of exciting to have discovered a new miracle food, just like that Eric that was discovered in 1600. So chips are health food, but also it was mostly the expensive bags that said so. So health is mentioned 6 times more on the expensive potato chip. We're talking about potato chips here. This is not foie gras. This is potato chips. But expensive chips mention it 6 times more often. We found different models of authenticity. The cheaper the chip, the more likely they are to talk about tradition. The company, the founders of the company, the year it was founded, all American things. The more expensive the chip, the more often they were to talk instead about some idea of naturalness and not artificiality. That the idea is that somehow the upper class is more concerned with not being artificial and being something real and natural and carefully handmade and not machine-made in some way. So just from looking at chips, we found all these interesting things about differences in how social class is presented in advertising. Expensive chips focus on health and this natural idea, and lots of negation, cheap chips on this idea of traditional authenticity. And so that led a project with Noah and Noah's collaborators Victor Chahuno and Brian Rutledge, and we thought, let's look at these in other kinds of food. And they started this without me, and then I joined in. And so we looked at menus from 6,000 online restaurants. And so what are the differences in menus if you compare cheap restaurants and expensive restaurants? So here's one difference. One difference is these beautiful adjectives: zesty, rich, golden brown, crispy, creamy. So here's some examples of these words. And if you just plot what are the dollar signs of the restaurants those occur in, let's use the Yelp categories, $1, $2, $3, and $4 signs. You get a lovely inverse U-shaped curve. Like it's the $2 and $3 sign restaurants that use these expensive adjectives. By contrast, the really cheap restaurants, what they use is not crispy and fluffy. They use very vague words that have kind of no meaning, like flavorful or freshly or delicious, which just really doesn't mean anything technically. So the cheaper the restaurant, the vaguer they are about the positive qualities of their food. So why would this be? Why is it that the cheaper restaurants have all of these extra adjectives, whether it's the vague ones or the beautiful crispy ones, and the expensive ones have nothing? And there's a standard linguistic explanation for this from the philosopher Grice that says, why would I mention something as fresh? I mention it's fresh because you need to know it's fresh. Why would you need to know it's fresh? Because you don't know it's fresh. And if you don't know it's fresh, that's a bad sign. You should be already assuming it's fresh. So by not mentioning it, I'm sort of keeping, if I'm an expensive restaurant, I just don't mention it so that you and I together jointly assume the food is going to be fresh. If I have to mention it, it's a bad sign. And for those of you interested in game theory, there's a lovely game theoretic proof of this, which you can ask me about later, but people have worked on this in game theory. And you can use this, lots of examples of this. So the word real is used only in cheap restaurants. In very cheap restaurants, you're guaranteed real mashed potatoes. In more expensive restaurants, you get real maple syrup, and you just don't get real things in expensive restaurants because they want you to assume everything is real. All right. You can even look at the history of innovations by looking at fake words. Just when fake foods appear, just 10 years later, menus proclaim that they have real versions of things. So this is the New York Public Library has a 150-year-old menu collection. So in the 90s, when bacon bits were invented, or 10 years after bacon bits were invented, people started mentioning that they had real bacon. And you can look at the inventions of fake whipped cream and fake sour cream and fake butter by when people start bragging about the real version of things. You can even look back, actually, at the great German immigration of the 1880s that brought actual beer to America. So Americans drank ale before the Germans came. And it was the Germans who brought beer. And people remembered that for the first 30 or 40 years until World War I. OK, so that's cheap restaurants. So what do expensive restaurants do? They use rare words. They use long words. And you can either long words that you don't know, like Tonarelli, or long words you do know, but instead of a short form like decaf. And again, you can run a little regression, price against word length, and you're paying 18 cents more for every average letter in the menu that you're reading. And then you can look at the length of the menu itself. So Janet, my wife and I, Janet, went to a very fancy restaurant which had no menu. It was a Michelin star restaurant. There was no menu. They just told you what you were going to eat after you had eaten it. And told you what you ate as you ate it. So we asked them for a menu, and they very kindly emailed us a menu afterwards in a very light font because they were just afraid we'd read it. And you can see it's one word per dish. Abalone, cardoon, brassicas, not a lot of information there. Notice that they say brassicas and not cabbage, so a nice fancy word. That's an expensive restaurant. By contrast, here's the Cheesecake Factory menu, page 1, page 2, page 3, page 4, and so on. OK, so what we learned is expensive menus are, the technical term in advertising is linguistically modest. And modest advertising is a way of displaying luxury status. We also found, just like with potato chips, more of this traditional authenticity in the cheap restaurants. The cheaper the restaurants, the more likely you are to get names of female relatives. The more expensive the restaurant, the more likely you are to get in the place where the food was grown. Like a huge spike for talking about the provenance of your food in expensive restaurants. And we get what I call the tiki lounge effect. If you are talking about a food and trying to sell it to non-native eaters, you use words like exotic, oriental, or even the word spicy. If you think about it, nobody calls your own food spicy. You only call some other cuisine's food spicy. And sure enough, when you use these words, meaning that you're selling food to somebody who's not a native eater, you charge more. OK, and so that's menus. And we also looked at restaurant reviews. So here's a sample of a 1-star review, somebody who really hated the restaurant, modified slightly so you can't Google it. So this is somebody who really hated the restaurant. What do you notice about this review? No mention of the food at all. There is no food anywhere in this review. So we thought going in, they'll talk about greasy food, and that'll be exciting. We'll understand the words for greasy food. So here's instead what we found. Here's what bad reviews look like. They have negative sentiment language, so words like terrible or awful. They are in the past tense, so they have words like waited and didn't and was. They mention other people, he, she, and managers and customers, and they're highly more likely than chance to use the first person plural pronoun. They use the words we or us much more often than they should. And it's a funny constellation of linguistic properties. So we went to the literature to look for other kinds of language that has the same, other kinds of genres of language that have the same collection of weird properties. So past tense, more we and us, negative, and their people narratives. And we found such a genre. It turns out there's one that exactly has these 4 characteristics. It's people who write after they've been traumatized. So this has been studied by social psychologists, people who, after 9/11 or or writing their blog post, or people who write after a tragedy. The idea is they use the past tense to distance themselves from this bad thing that happened, and they use the we's because we together are going to get through this bad thing jointly, and this bad thing happened, but together we'll get through it, it's us. So that tells us that these one-star reviews somehow are a genre of trauma narratives. It's a minor trauma, nobody died, obviously, but they're still traumatized, and that tells you that the reviews aren't about food. They're also about food, but they're really people talking about their interactions with the world, and these one-star reviews are all about somebody. We read the reviews, it's people being mean to people. People are traumatized when somebody is rude to them, makes them wait, is mean. So that's the lesson from the negative reviews. We also looked, of course, at the positive reviews. Here's some positive review phrases. So you'll notice that they're all about sex. And you might think, oh, OK, positive reviews are all about sex. It turns out it's only the expensive positive reviews are about sex. So sex is somehow modeled as an expensive luxury thing. How we talk about cheap food that we like is very different. We use words like addiction, crack, or craving. The cheaper the food, and you can see these are beautiful symmetric graphs. The cheaper the food, the more we talk about it as drugs. So why the drug metaphor? Well, obviously, we're feeling guilty about eating these junky foods, and so drugs is a negative thing. But even more than that, drugs is a way of eliminating the agency. If I ate the cupcake because I was addicted to the cupcake, it's really the cupcake forced me to eat the cupcake. It's not my fault. Interestingly, we do see gender differences. So we know from lots of research that women are much more pressured to conform to healthy eating norms, and they were more likely to use this metaphor of drugs. Men, by contrast, were much more likely to report, to display this language of trauma. So women are guilty and men are traumatized. OK, so in summary, we learned from menus, we learned about the economics of modest advertising and all of these interesting differences in class and things like health and authenticity. What we learned from the reviews, I didn't talk about the request, is we can see linguistic signs of trauma in something that you might think of as an everyday thing that you were looking at it for some other purpose altogether, and these really complex attitude towards food and the body. And so I want to conclude by saying innovation in science happens when you talk to your neighbors, so go talk to your neighbors. And if you want to learn the language of a community, you have to be invested in that community. If you're not invested, you're not going to learn. That people suffer when you're mean to them, and they reward you when you're kind. And in general, you can just tell what people think if you look very carefully at the words they're using to talk about things. So I think I'll stop there and take questions. Thank you.
So the Ketchup model of innovation is very compelling as an alternative to just the Kuhnian internal paradigm shift. But it immediately raises a question which is, how do these connections happen? Are they just random, right? I mean, there are lots of communities that could interact with lots of communities and people that could this and that, and most of the time nothing happens. So the deeper question is, what is it that causes something to happen?
Nice. Just repeating the question for in the back. So Paige's question is, it's great that in the history of science that this particular electrical engineering community came and computer science adopted this innovation, but what about all the other communities that happened to drop by and the innovations weren't adopted? How can we predict which innovations will get adopted? So I don't have an answer to that. It's one of the questions we're interested in. But yeah, clearly here, and that's part of the second part of our paper, it was clearly midwifed by somebody who saw that community's results, was convinced by them, and forced them to tell it to this other community. So in this particular case, there was a midwife. It was some people, some program managers at ARPA actually influenced it.
I think maybe part of it is also that the community itself was going through a near-death experience, which made them more open to outside influence.
Yeah, I mean, that could be, although, so there's, as those of you in my field know, there's been a massive change in the last 18 months toward the adoption of neural net models, which first hit the field in the 80s and then kind of disappeared mostly and came back with a vengeance. And we're all learning all these new models now. And I don't know, people have asked me, so I worked on neural net speech recognition as my postdoc in the early 90s. And the people I worked with on that postdoc kind of kept working on it. And it wasn't working very well when I was a postdoc. Of course, it's my fault. But now, but it got slowly better over the years, and various innovations happened, and it sort of reached the point where it just seemed to work, and then magically everybody wanted to do it. So that's one narrative, that it could be that that in the case of statistical revolution, that happened because it seemed to work, and someone was convinced enough that it worked to make people tell those computer scientists, they'll try it too. And that seems to be what happened with deep learning. So the two examples that happened in my lifetime that were large to my sub-community are both cases where something spread because the grad students could use it to solve a problem. And that is the CUNY model, right? The CUNY model is the old people, they don't change. When a new innovation happens, because when a new innovation first happens, it doesn't work as well as the old stuff. It's not quite as good. The old model with its epicycles of how the sun goes around the Earth, it's gotten very good by now. That model is full of little details that make it completely predict the actual appearance in the sky. And the new model is kind of wrong for a while. But the grad students don't care. It's exciting. They can get a thesis out of it. So whereas the old people are like, it doesn't work as well, and they die off, basically. And yeah.
So one elegant thing about your talk, which I really loved, is that in addition to the observations, you assigned these interesting interpretations like one-star reviews or traumas, which is definitely my experience personally. And so I was thinking particularly about the DARPA thing and what's the right kind of interpretation to assign to that. And one, of course, is that we should be following DARPA's vicissitudes, and I'm not sure that's the right interpretation. But another one is that when you force things into a clear metric, right, which was done with these bake-offs, and the other great example in my mind is with chess, right, where initially we started and there was selective ideas of selective, and fundamentally you could tell who was winning, who was losing, and that led that field arguably to advance very, very rapidly. So I wonder if you would agree with the interpretation that taking our wonderfully creative research ideas and forcing them in certain instances to a clear competitive metric helps to drive the field forward.
Yeah, nice. So Oren's, again, for those of you in the back, Oren's suggestion is, could it be that the reason why innovations succeed is, or at least in these particular cases, the case of the Statistical Revolution was that they gave us a metric, an evaluation function that I would say, two grad students could say, hey, my thing is better than you, I can publish my paper now. And I'm convinced that's true. I'm convinced that, you can argue that there's over-evaluation and over-bake-offing and incrementalism in science. So Chris Manning, in his presidential address to the ACL, to our community in the summer, said, everybody's a little worried that there's too many incremental results, and there's like people getting 0.5% improvement on somebody else. Nonetheless, it's way better than when I was in grad school, which was, it was really unclear what constituted an AI. You're my generation. What was an AI thesis back then? It really wasn't clear at all what constituted progress in the field, and how, if your thing was different than someone else's thing. You just, it was a narrative, it was rhetorical structure. And so I'm very happy to have metrics. We also want revolutionary changes too, but maybe we're getting those anyway. So yeah, I'm convinced that that was a big part of the change. And that was clearly top down. That was DARPA telling the researchers, you must have a shared evaluation metric, and people fought it. And so that, yeah, this may be a case where they were right.
So in this W example, I'm kind of curious about change at the personal level and the community level, because it's quite plausible, like these people just came into the other community with the same tools they were using, and they themselves maybe didn't innovate. They just did their same tools in the new community. In the new community, but they were doing the same things they did before, versus, say, innovation at the personal level.
Yeah, interesting. Yeah, so for example, in the example of like statistical machine translation, which was invented by statistical speech people, just taking the exact same model. But then, of course, they had innovated that model too. Like that model was, HMMs came out of IDA, and they came out of like classified research that we don't actually know who invented it, somewhere behind some wall. But it started to appear 10 years before those people applied it then later to machine translation. But they had sort of innovated it, and it wasn't like it was static that whole time, I guess is what am I answering your question? I'm not sure I'm answering your question.
Yeah, basically, it's not quite immediately clear what the question is how to disentangle a couple of different effects, because there are sort of big peaks, but it might just be the same techniques in one community just moving over versus something homegrown that's very...
Yeah, and it's kind of like the internal versus external revolution case. Could we could we compare, what counts as a revolution? Is it, you're saying, yeah, what about the internal revolution? Like, was this could have also been, that's kind of was my vague answer, this could have also been a revolution in EE that also became a revolution in CS, or it could have been boring old science as usual in EE that when applied to CS became a revolution. So yeah, that's a good question, and we should be able to distinguish that. That's like actually a research thing we should look at. I like that. Because yeah, I'm saying, oh, let's look at stuff from the outside, and your point is we really have to see revolutions both from the inside and outside together. Mari.
From having been there, I would comment that I think there was change because the people were working on different problems. And so they took their ideas didn't necessarily apply directly. They had to change them. So I think there was change on both sides. And I think, but the other thing, we called it the arranged marriage. And I think it wasn't just the benchmark. The benchmarks are certainly important. I think the money was really,
yeah, the money got people to show up.
The money got people to show up, and they were required to talk to each other.
Yeah, I mean, that's why I was a grad student. I was there. I was like, oh, this looks interesting. Maybe I should do this. Yeah. Yeah.
Actually, the same change took place in computer vision. For a number of years, controlled by MIT, mainly, the computer vision community refused to use statistical techniques. And then at some point, they finally gave up, and now statistical techniques are everything. And it wasn't a forced marriage, it finally just happened.
Yeah, nice. So, so really we need to look, as we're doing, so what we're doing now, I said there's a big project with lots of people, is we have Web of Science, the Thomson Reuters big corpus of all journal articles in the last 30 years, and we're looking to try to replicate this study on a larger scale, like what happens with innovation across lots of fields. And it's much harder, because in computer science, I know exactly what the papers are and what they meant, and I remember the innovations. And in some subfield of biology, I have no idea if something's an innovation or not. So we have to talk to a lot of other people, which is probably good anyway. Yeah, in the back there.
So given this idea of like talking to your neighbors, what role, if any, do you see, like, for example, like people in humanities, like rhetoricians or cultural studies scholars, like who are doing maybe like similar work to the Menus project, like what kind of overlap do you see between?
Great, yeah. So what overlap is there between this work and like digital humanities work and maybe even non-digital humanities work in anthropology so I think of it, okay, from my completely biased, linguist and computer scientist view, I'm like very happy to have lots of people think about language and computation in every academic discipline. So I have a couple of students interested in poetry, and one working on dialogue and narrative, and we're collaborating with people in the English department on using these techniques for digital humanities kind of things. So one thing that I was talking to the grad students earlier today, one thing I've noticed is when I work on problems in anthropology or in sociology, or it's always a collaboration with somebody in that field. Sometimes a grad student's always a faculty. For the collaborations, like I'm also working on the history of language change. For the collaborations in language, I'm the social scientist. But for the collaborations on, let's say, literature, we find a humanities person or a social scientist. So one answer to your question is collaboration is good.